Right. So our next speaker is also, again, I'm lucky that good friends of mine are presenting here. She is person that also loves to go to museums, musea actually, and she enjoys some time here in Rotterdam. Yesterday, visiting a museum. So Rotterdam is a very nice place for looking at art and many things that are interesting, photography and all this kind of stuff in museums. So also, if you're staying here in Rotterdam a little bit longer, take the opportunity. But today we are going to continue with our nice talks about Postgres, and we are going to see the anatomy of the logs in a table that are going to be presented by Gülçin Yıldırım. Thank you.
Hello. Thank you, Boris, for the nice introduction, and thank you, everybody, for organizing it. And I'm really happy that in the morning we have a full crowd. It never happens, as Jimmy said. I was expecting few people, and so it's like really dedicated conference people. I really like the energy and also maybe the vibe with the music. And it's nice to see so many friendly faces that are, long-time friends and also new faces. So I'm happy to meet everybody. Okay, so who am I? I work in a company called Zeta. That's how we pronounce it. But I think it's in Spanish. They can even say it like chata or something. So there are multiple ways to read it, but we say it Zeta. I don't know. It's a Postgres platform. You can check it out. And I was recently recognized as a Postgres contributor as well. I'm happy to be one of them. And I live in Prague, and we organize Prague Postgres meetup with a couple of friends. There is Major here, and there is Tomasz taking my pictures. So if you ever happen to visit Prague, we regularly run this meetup over 8 years that I'm involved, and it was even there before. So if you ever want to make a reason to visit Prague, just use this as a I'll just go to this meetup. And I also run a community over, 12 years, I think, maybe 13 now. Called Kadın Yazılımcı. It directly translates as like women devs in Turkish. And we run our own conference. It will be the 4th time next year. It's called Diva, where we actually bring people who are from different fields and academic and also like other industries and like other fields of software technologies to talk about how AI actually change in the way that they work and what kind of inventions they come up with. So we actually understand like what happens in the databases, the front end side of things, the whole life cycle of our jobs, basically. I think, yeah. And again, if you want to visit Istanbul next year, that's also another reason. Soon we will open the call for papers for English as well. So anyway, so let's start. As Boris was saying, and we really didn't coordinate with this, but I was in yesterday, I had a free time and he knows me well that I was, going to the museums a lot. So I only managed to fit in one museum, Kunsthal, if I'm pronouncing wrong, I don't know. And they had really nice exhibitions. And one of them I also see an elephant. And as we always find elephants, I always see elephants everywhere. It might be, like some bias, right? We know. And it's really good. And I'm really happy to be here. I had really good food and really good coffee, which are really like main criteria: art, coffee and food. And Rotterdam checked all the marks, and also great crowd for a conference. So happy to be here. And what we will talk today, it will be about, there was the survey that Jimmy mentioned that people really would wish vacuum away. And one of the reasons that we have it is also comes with MVCC architecture, which we will talk about it soon. And main focus will be about why we actually log and how Postgres logging works, specifically for DDL logs, and how we can actually reduce this impact. So you will see the examples of some queries and how we can make things better for, reduce this impact and reduce the log contention. And at the very end, last 5-10 minutes, we will talk about an open source tool called pgrole, which I helped develop in the company that I work for. And yeah, if you try it, please let us know. Okay, so why I started to think about this topic, because when I joined Zeta, I was going through their open source projects, and that one of them really interested me, the pgrole, because it's kind of the message or the motivation is to make schema migrations near zero downtime with, and some people end up in the, with the logs, and how can we avoid people to fall into this? And I was thinking, okay, I should actually maybe explain think about it a bit how Postgres logs work. And I wrote a couple of blogs about it, and then it became a talk. But when I was writing the talk, and I'm known to be postponing my talks, writing, and then I was like, okay, maybe I should read books about logs. So I bought lots of books about Persian logs. I don't know how to do log picking, and I just like enjoyed a bit of reading before actually think about Postgres logs. But one thing is, it's not really alike. Like this physical logs in the real world is about security. So you have some money, I don't know, some important things, documents that you put in a safe. It's just to secure it away. But in Postgres, it's all about concurrency, nothing about security. So that's didn't bring anything. But one thing is like I can draw similarities between physical logs that I read, the log picking especially, and how logs work in general in Postgres, that to be able to pick a log, you need to have understanding of how this inner workings of a safe or a log work. And then you don't really need a key to unlock it, right? That's the whole point about it. You just understand these tumblers and mechanisms and switch them in a way that it actually can open. So the same way, to be able to understand how logs work in Postgres, you need to understand a few things. That definitely goes back to the how concurrency works in Postgres. Once you understand it, you will probably understand the impact and how it works with the logs as well. Okay, so how does actually Postgres manages this? The one thing that is like, I think to avoid many of the logging issues, we have a system called MVCC, and it is not something specific to Postgres. There's a lot of database systems and other software systems using it. The idea is like, when you write the new copy, like when you write a data, you create the copies of it. So instead of updating the data in the same place, you actually create multiple copies. That's why there are like this multi-version concept in the name. And why do we do this? So that we can ensure that reads are not blocking writes and writes are not blocking reads. You probably heard this term all the time, and you look at the MVCC documents, this is what it comes. But actually, this makes Postgres really efficient if you are doing concurrent DML operation. This is how Postgres solve a lot of locking issues that can come with this problem. But even in this MVCC-based system, there are some levels of locking is unavoidable. You will still, reads may not block the writes, but they might still acquire lightweight blocks and the objects like, I don't know, database objects like tables, views, types, stuff. And the other complications will come from that you really expect a statement or maybe sub-statements maybe to take same level of locking, but they don't. So the sub-commands will have different level of locks than, let's say, an alter table. It will not be always getting the same level of locks. And that's why I think it actually makes things a bit more hard to comprehend. So there is this like simple example. I think it makes it easier to understand this theory of it. And before we start that, I would like to maybe explain some of the stuff. So when, let's say, a transaction is updating data and Postgres is creating another version, but it still keeps the old version. And each of the row versions, that there are some system columns that it's included. They are, unless you search for it, they are invisible to you, but they are crucial for the MVCC to work. So two things that if you know, that's probably enough for this example. Xmin is a transaction ID that creates that specific version. Let's say when you update it, it's the Xmin of the new row that will be that created this version will be the Xmin of the transaction that updates the data. And then the Xmax is the one that actually deletes or updates the version. So if that is the older version, you will see Xmax there of the transaction that actually updated will be the Xmax of the previous version. And the example you see here is actually a reflection of how Postgres behaves in default isolation level, transaction isolation level that is read committed. So if you run this example in a different isolation level that you change, you will not get the same result. So the explanation of this example is how it works in default. And how does it work? So every time a statement begins, Postgres creates a snapshot. And that snapshot has all the transaction IDs at that moment, latest committed transaction IDs, and then list of in-progress transactions. And so in this, let's start with the query, the first query. So there are like two transactions here. High-level transactions, I may consider them as like transaction 1 is 100, and then transaction 2 is 101, and there was a transaction before that actually had this data. So what I do is like I select a salary of the Alice and I see it at 50,000. And so it's starting, it's get a snapshot for the select and it sees it at the 50,000, right? And the rows X max is null. And that means that this is the current one, and X min before is 99. That's why it's visible to us because it was already committed. And then the second transaction that comes, that's the 101, and tries to update the salary from 50,000 to 60,000. And now, instead of doing it in place, right? So this created the other version, and the old version marked with the Xmax 101 because that is the one that is actually updated this, right? And then it created the Xmin 101 so that it actually created this version. And now, when the second transaction commits, if it commits, it will make the changes visible to any new snapshots that starts. But when we do now, I'm running another, before it commits, I'm running another select, and I still see salary 50,000 because 101 is not committed yet. And after transaction 2 commits, I'm running the third select, and then it again gets a fresh snapshot, and there now it sees the committed transactions. So now the salary is 60,000. Basically, this is how it actually simply works, and that's why we can actually serve different things, right? The queries who are actually seeing the old version, they can keep running it, and then now we can also operate with the version that we want. But of course, as we seen in the Jimmy's brief as well, these dead rows will accumulate until cleaned by a vacuum process. And that's why it's really important to tune auto vacuum settings, and maybe we can do better there, right? I mean, it can be also, improved in Postgres itself. But that's why vacuum maintenance is essential for the performance. You don't want this. But yeah, if you finish with a good node, it's important that we have it so that we can actually have consistent snapshots for the long-running queries. And hopefully they won't run too long because they will have other issues. So we actually, without having excessive locking, we sorted a lot of the problems can come with the, high read and write workloads and requires concurrency in Postgres. Okay, so clearly logs are not something that we would like to have, right? I mean, whatever the type is, it will definitely reduce the throughput, it will potentially increase the latency, and it means that also performance, nobody wants to have that. But if my intention is to make sure that my database, my data doesn't have corruption and everyone is getting a correct result at their time of query, I have to have an agreement, basically. I have to log access when multiple transactions targeting the same resource, and I want to show things in the correct way. That's why we have to log. We can't really avoid it. And I think it's something to think because there are two extremes, right? There's a scenario that we never log, and then it's like a hell, right? Health can lose easily. We can all imagine it. And if we have to log for everything, that's the other extreme, then it will be pretty much impossible to work with unless you are serving one user that does at a time in one resource that doesn't have anything to, worry. But that doesn't happen. So we really have to have an isolation level agreement, basically. That's what we talked with read committed, but you can actually do different layers, different levels based on what you want. And that will come with this. Okay, so why? Because there are multiple types of logs in Postgres. Like I heard in PGD Austria last week that Lawrence Albe is actually inspired by this talk, and he wants to do his own version of anatomy of row level logs because that doesn't cover, this talk doesn't cover that. Hopefully Lawrence will, I'm sure he will cover it very well. And my focus was DDL because that's what happens, right, when I run an alter table, when I have a vacuum full, that they require often stronger logs. And the one that we are trying to avoid is the access exclusive log. And maybe people don't really think that some operations, okay, they can assume that it will block the other DDL commands, it will block DML commands, and some of them actually select. So it means that the access to table can go all together. So you might have downtime. So this is not maybe considered every time when you are planning these things, but it's something to think about. And we will talk about it soon. Okay, and also before we go further, I divided the presentation with this little kind of, let's say, checkpoints or milestones. If you don't take anything within these pages that I talked before, you can just take these notes with you. There are 8 of them or something. There are more simple information. So first one is very clear as we talk. MACC protects you from writes blocking reads, but not we can't totally avoid the locking. We have to take it, and some different variants of the same commands may require different levels of lock strength. And these are all the table level lock modes. I colored them from the kind of least restrictive to the most restrictive on the bottom. And the ones that are related to DDL is the ones that I marked is like purplish pinkish, because before there is like DML queries and selects and so on. So they are not really focus of today's discussion. So you can just look at the few examples. These are not definitely an extensive list. So there are like, if you want to see what statement gets what log, you can actually go to documentation and find it. It's not maybe the most straightforward thing, but it is there. And maybe more important than this list is like how these log modes interact with each other. So how, let's say, for example, share update exclusive. This will conflict with share log exclusive log, and access exclusive log. But it is not really straightforward. You really have to see how they operate. So there's a matrix in the documentation. You can look at it, how they conflict or interact with each other. Okay. Yeah, that's the first point. Basically says that it's more important how to see the conflicting between each other. And there are like maybe a few things to understand that from the previous page and here. And access exclusive will conflict with everything. So it means that it will conflict with the access share, which was the least restrictive log, but that means select. So it will block the selects, and that's really what we are trying to avoid. Of course, Postgres is not stupid, right? It has lots of optimizations. If it can take a weaker log, it will take the weaker log. It will, like, if it can, it will do this, but it's not perfect. Sometimes you really have to take the strong logs on some DDL operations. You can't avoid it. But the last point here is an important takeaway, because it says once a transaction takes a log, it will hold it even if the statement has finished. What does it mean? Let's say you have a transaction, and in one of the statements you have to take an access exclusive log, but then you don't really you do some updates, for example. The first one is an alteration. It needs this access exclusive, but the updates would be doing with a lighter log, let's say. And if you put them in the same transaction, you will unnecessarily hold this log during the whole transaction length. So thing that is to take away from here, separate these things. So if you are doing don't mix the commands that require strong logs with the others. So if you are doing table alteration and data updates, separate them in different transactions. So there's one way to easily minimize blocking, because you don't really want unnecessarily the end log to be held for the whole transaction length. You don't want to do that. So separate them. Don't put them in the same transaction. Okay, so how actually Postgres log queue works, right? This is how it's handled in the Postgres. So there's a locking queue mechanism, and let's kind of try to understand this easily. So let's say a transaction that wants to acquire a log, and it's already conflicted with some other log that is there's a log already held by another transaction, and these two are conflicting. Then the waiting one will enter to the log queue. And so catch here is that by default, this requesting transaction will wait indefinitely until this log becomes available so that it can actually acquire that log. And it is really, I don't think, known by everybody that it can actually become a big problem if you don't set your log timeout accurately. So set it so that you know that you will not end up waiting forever if this happens to you. And so these waiting logs will form a queue, and again, it's not unfortunately visible directly in the PG log system view. You have to use this PG blocking PIDs function to see which backend is blocking a specific backend. That I think could be also improved, to be honest. And the other part is at the very end, the logs that are ahead in the queue can block the logs that are behind them, and this will make a cascading delay, and that's really how the log contention happens. That's the state that we don't want to end up with. And that's what we will see in the example that I will give later on. But yeah, takeaway from here is set the log timeout, if not for everything, except at least for the DDL ones, so you don't really end up in this state when you're trying to just change a table, alter a table. And for DDLs, you have actually a bit of more control, I feel, because the applications usually don't really, rarely run, I think, DDL. There's either a process that you do these migrations or vacuum or maintenance. So there are either workflows that you set for them that you are in control, or somebody does these things. So if you at least set log timeout for these statements, you're already, I think, more secure. But then, of course, it comes with also some catch again, right? You had the log timeout and some things will time out. And what will you do then? You have to handle this gracefully. So you can have either, some rollback thing or retry this again later. So you need to think about that too. Like setting log timeout will not actually maybe make you happy in the long run. I mean, it's still better probably than the other case that you don't set it and then things wait indefinitely. But again, you need to handle these errors that you will get if you set the log timeout. Okay, so this is the example, and that makes it much simpler. From now on, we will see queries, and I don't know how it makes you feel, but it makes me very happy. We can just talk about the queries instead of the other things that we already talk in the high level. So imagine I put an example here. There is a long-running select, maybe runs once a month. A department is running a long query. Everybody thinks that that's okay. Yeah, we know that it will take, 30 minutes or something every month. But then I am trying to run an alter table detach partition, very particular query because it's a real example. And that needs a brief access exclusive log. It will take this ideally, but it can't take the log because this will conflict with select that is already holding the log. So we can't really operate here, so they conflict. The alter table will be placed in the log queue. And then another 20, 30 backends is there trying to do simple primary key lookups, basic selects, and they conflict with the alter tables log. So they have to go behind the alter table operation as well. So what are we in the state that all access to this given table is now queued behind, no processing is happening until the long-running select that looks like normally innocent to people, that finishes, and then the alter table finishes, and then we're able to operate. We will be able to serve for the other selects that are queued behind of both of these things. So this is not good, right? So it's like it might significantly impact the performance, and that's why it's important to set the log timeout definitely. But I think it's also a message that we should be mindful of long-running transactions, especially before you run a DDL command like this. You need to have an understanding of what's happening in your database before you actually do these operations. Yeah. That actually brings me to takeaway 4. Any long-running query, doesn't matter the type, it might be just a simple select that happens very rarely, can be actually important during the schema changes. Be mindful of them, look at it, and set the proper log timeout values for them. Okay, and so far we always talk that as if logs are unavoidable. In many cases they are, but there are things that we can actually, simple techniques that are not invented recently, they were all in documentation, but this talk brings them to you to see how we can avoid some simple strategies to reduce this log contention that you don't end up in the bad place. Okay, so first thing is really simple. If there is a concurrently command that is working with your statement, use them. Because what I mean, for example, creating index concurrently, I think pretty much everybody knows in the room. Or in the other example, alter table detach partition also has a concurrently. And if they used it, it wouldn't end up in the critical state because they were having a script. This was a very big payment system provider. And they were doing this detach partitions regularly, but then something changed in the script and they forgot to concurrently, and that ended up in a bad situation that it was an S1 ticket escalated to everybody in the company that I worked before. So it's it can happen. So if they had the concurrently, they wouldn't end up this issue. But of course, this is not set the concurrently and forget about it. That's what I mean. Of course, there is when you decide something, the cost comes with it. They will be definitely they will take longer to complete. And these are also not transactional, so it means that you can't really put them in a transaction block and they can't really roll back because of this, right? And they will require better care, let's say. It's not as simple as like, okay, I run the concurrently, I'm done. Because inside of the Postgres, they will be run by different transactions. So they might actually, there's more risk of things not ending up correctly. So they might leave like, I don't know, partial changes and then have some failure in some place, and then you'll have to monitor them. But there are commands, like for example, for this detached partition, there are commands like finalize, so it can clean up or finish the work. So no need to worry, you use these things, but be aware that you need to treat them a bit more care. And maybe I want to talk a bit like if we run the detached partition concurrently, how would it work? Without concurrently, so basically there's a main table and there's a partition that we are trying to do this detach operation. The both main table and the partition that we are trying to detach will take access exclusive lock, both of them. And basically that means that the main table, while this partition is being detached, will not be accessible. And also the partition itself will not be accessible to do even reads or nothing. So it's total loss. And then if we were running this with concurrently, we would use 2 transactions internally in Postgres, and then it will actually minimize the locking impact pretty well. The first transaction, it does like main table and the detached part table that we are trying to detach, none of them will take access exclusive. They will take share update exclusive. That means that it will allow the reads, but of course it will block the schema changes, which you don't want it. You don't want to add and remove columns while altering this partition. It will not allow this to do this. And the same with partition. Still, partition will allow the reads while it's being detached. It wouldn't, of course, it will block again the schema changes and so on, but this is already better. And then after this point, after this transaction completes, this is marked as like undergoing detachment, and then Postgres wait other sessions using this table to finish, and then it will start another transaction internally, and then on the main table, we will still not get access exclusive in that transaction. We will still get the share update exclusive, which is better. In the only, we will take in the partition one when in the second transaction, access exclusive. And that's needed, right? It still has to take it, but the impact of it is much less reduced. It will not bothering the main table at all. And then it just finishes that and adds a check constraint to enforce the partition rule, and it's done with it. I think it's super smart, and this is one of the optimizations Postgres have it. So let's benefit it and use it. Okay, so now other things. We said about use concurrently. What other simple strategy is like, if you can break down the large DDLs into smaller and less blocking steps, you can use it. So let's imagine you want to add a not null column with a default value. And so we know that if we run this first statement there, alter table, my table, I'm trying to add a column with not null, and the default is a volatile function. That's why it is taking this. So this will require an access exclusive lock for sure, and it will rewrite the entire table, and for this whole table, there is no access to the table. You don't want it. And it can take, I don't know, based on how big, it can be minutes or hours, depending on how large the table is. So instead of doing this, let's separate it to the 3 steps, smaller steps, and see how it works. So first, I'm adding a column that is nullable. I don't add the not null here. I'm adding with a default again. It's the same function. Then in the second step, I'm populating the null values. So I'm running my update as a second step. And again, ideally, you should run these things also in batches, because you really, again, remember, you don't want to end up creating long-running queries at all. So run this update in batches too. And then at the end, I'm adding the not null constraint. And what is the advantage of it? First advantage is the initial column addition that we had. Now it only requires a brief access exclusive lock. Otherwise, it will be much longer. And the data population, it'll be with the, since it's a DML operation, it goes to a different level of lock. It will be row exclusive lock instead of access exclusive at the same time. And it will actually allow the operations to go. And that's already much better. But we will see if there is a way we could actually improve this even further. Okay, so in the last step of the previous query, we still added the not null like this in the first line, and then it will still take a long time. It will still block the writes while this is happening, but of course it's an improvement because it doesn't block the reads at least. So it will be already shorter than the original one. It does only one table scan. But anyway, so we can actually do this much better, and we leverage here check constraints. So what do I do instead? So I'm running an alter table. I'm adding a constraint, check constraint, but I'm adding it as a not valid. And then I'm validating the constraint in the second one. I'm running alter table, my table. I'm validating the constraint here. And this scan during the validate constraint is not blocking the writes. Why so? Because it actually only cares about when it's validating, it only cares about the data that's already in there. And when you are adding the check, when you edit the check itself, it actually only cares about the new ones. It doesn't care about existing data validation. So it's already a smarter strategy. And then at the end, you have to add the not null on the column, right? Instead of the check constraint, you have to do this. But now Postgres is really smart because it's aware that is actually what it needs to be done is done already. So it's a simple metadata operation. There's a valid check constraint. Postgres understands it, but of course it will still take a brief access exclusive log to do this. And then you remove the check constraint. Now it's redundant, obviously, and then you are done. So the strategy is that we managed to divide how we treat the new insert, how we treat the inserts, and how we treat the data that we already have. And that's how we did it with the invalidation and then validating it later. Okay, so the takeaway 5, and we are in the, I think, later parts of the presentation. Try to find an approach that does the less locking, and that will definitely need some expertise. And if there are tools can help you do this, also we can use that. Okay, and another thing, remember the query of the adding not null query. And before, if you're using an older version of Postgres, running this like add column not null and default with 1, you will be still treating it as like the query that we run with the function volatile function. Because now Postgres is smart. Now it executes very quickly if you're running in a modern Postgres version, because it can see that it's a constant value, and then I can store it as a metadata, so I don't need to rewrite the whole table for this. But if you are using an older Postgres version, it will behave the same way. So that brings me to the naive takeaway. If you can, and if you are able, and if your organization allows you to do that, promote for upgrading to modern versions of Postgres. And I was asking in Switzerland this year, and there was like people who are running Postgres is between 8 points. I don't know who is running older than 8. Is there anybody running older than 8, like 8, Postgres 8 here in the room? Redshift. Oh my God. Okay. Maybe 8.5, 9. Is there people in the Postgres 9? That's a modern room, definitely. Like, because in Switzerland, I was like 8, and this actually, it's also good, right? We know that Postgres can still run on the older versions. It's amazing to me. Like when I started Postgres, it was like, yeah, I was running version 8 too, but it was a very long time ago. And I'm happy that people can still operate in their production systems with these versions. That is also a nice thing. But if you can basically avoid it, you can avoid it. And yeah, use the optimizations that are already included. Okay, so we are almost at the last part of the presentation, and I will do, let's say, a bit of plug, as Jimmy was saying, the project that I'm working, PG role. And the motivation of this tool was like why they built this tool before I joined. They wanted to have log-free migrations. They want to handle the data backfilling that happens, right, as we've seen there are updates happening. And there was also a big problem in the customer base because people usually, when they plan schema migrations, they have kind of like playbooks for it. Like, okay, this application will be stopped, and then you need to run this operation. And then if things go back, there's this rollback script, and there's steps and steps and steps. There was a famous company with like lots of steps for how to handle the schema migration. And it shouldn't really need to be this way if we can actually avoid it. But there was also the way that there's PG role work is also designed to have multiple schema versions at the same time. So basically, there are like 2 versions of your schema active at the same time of the migration that's happening. So there's the old schema and the new schema. So that means that old versions of the client applications can coexist with the new versions during the application rollout, because they both see a different version of the basically database schema that they expect to see. You don't really need to do it this way, right? Schema migrations doesn't need to be this way, but this was designed basically to handle people to do kind of blue-green type of deployments, the like application rollouts without downtime. And that's why it was built the way that it was built. So that's why it has the schema versions, multiple schema versions. And this is like a choice that I was not basically understanding at the beginning, but instead of writing the direct SQL, we do in PG role with the high level operations. So there's an add operation, I don't know, add column operation, change type operation, and so on. And before it was like with JSON. When I joined, we made it with default YAML. I think that's more usable than JSON. Maybe for the people in the room, they would agree. It's not for developers, perhaps, that are used to modern, I don't know, JavaScript way of writing things. And then also we have the spec-filling of data. You can also define it here. How do you want this thing to be operated? But the idea is like, let's say you are adding a new constraint, not null constraint, let's say, and you add this, and the new versions of your application wants to have this constraint. So if they are trying to enter null data, they will just say, okay, hey, you can't enter null data, but you still also serve for the old versions of your, old versions of your application that also is able to enter null data. So what happens? So we transform this null data that comes from the older version in the new table setup that we want the new applications to behave, because they want to have the constraint. And that's how we do transformations. And this is what it's like up and down. So both ways are kind of aligned, and you can define how they should be in the background, so you don't need to worry about it. But I like this picture pretty much, because do you see this middle red area? You start the migration, you do the rolling upgrade, and at this red spot, they are both running simultaneously, the application versions. And you can keep this as long as you want. You can test stuff. And if you are happy with what you tested, you can actually move on and continue and finalize your migration. That will be the new version. If you are not happy, you can roll back. Because there are a lot of schema migration tools out there. Not many open source, I think, but there are a few. But the people, like the enterprise or, I don't know, closed source tools, they treat rollbacks as a premium feature. I was very surprised. I mean, what is the point of this if you can't even roll back? Because maybe in their design, it's not designed this way, and they recommend always roll forward. And rolling forward always is not really, I don't know, you will end up with the things that you not necessarily want to have, and then you will work around it instead of you could actually here roll back. I think that's like what makes it kind of unique. If your type of migration is like blue-green type of migration, that will be useful for you. And yeah, so basically, until migration is complete, you can serve both versions. And this is how it looks a little bit. We are using some pattern called expand and contract. That is also not something new. It's a software pattern. What does it mean is that you expand the table, you add this in the physical table, that you add these things that you want to add, and then you do the migrations, and then you contract, so you drop the things that you don't need anymore. That's why it's kind of expanding at first and then contracting later. But people, like from the same table, right, we have different views. That one is like seen by the older version of the apps, and the other one is seen by the newer version. So you have double of the views from the schemas, that different schemas point at a different version of the view, and that's still attached to the same table. And then you do this manipulation by setting the search path to point at the schema that you wanted. And we already talked about, we handle the spec filling automatic. And good thing is that you can actually control this, because remember, I wanted that if you do the updates, you need to do it in batches. And we allow you to do basically define the size of the batch and the rate of the batch processing and so on. So that's also, I think, beneficial. Yeah, this up and down migrations and the data backfilling happens with the triggers. But anyway, if you want to do it this way, you have to have this data backfilling sorted somehow. Maybe the good thing about it is that now all this logic is out of the application and it's more closer to the database layer. That's also very convenient, because we all know that schemas are not static things. You don't start your database, okay, these are my tables, these are my columns, I will never have to change anything, I will never have to add an index, I will never have to change a type, and so on. So we need to plan for it. Like schemas are evolving, living things. and like databases and applications and the users of this. So it's important that we can actually handle the migration story. And remember, there was this log timeout discussion. We actually generate the alters prefix with the set log timeout, so that you know that you will not end up in an indefinite time of waiting in case there's a log occurs. And then we also have the trying again logic included. Okay, so this is it pretty much with the PG role. And yeah, if you try it out, let us know. I would be really happy. I individually read all the issues that are opened, all the PRs that comes. So really happy to see activities after conferences. I can see that, people are actually looking at it. It makes me really happy that I actually, the talk actually reached some people who might actually benefit from it. And yeah, if you are using, mainly I think what I need from the people in the room, if you are using a specific ORM or different way of handling these things, I really like to know basically how do you perform the schema migrations? What is your developer environment look like? Because based on that, things can change, right? Like, because we have like commands like convert or something to transform this ORM generated SQLs to the PG role operations, but it's not always very simple and not everything tested clearly. So I will be happy to see different ways of how people are using it. And I keep blogging, and if you are not following Planet Postgres, please follow Planet Postgres. There's a blog aggregator, and it collects all the blogs that we all write from the community members, most of us at least, and big companies also blogs there. So if you are not following it, follow it, and I really learned a lot from that. Yeah, dankjewel. I think I really overused my time. Boris was like, no.
So, we are going to have Gülçin. You are going to stay here the entire day, right? Because
Yes.
you want to answer questions during the break or during lunch or whenever you find her, she's going to answer all the questions that you have. We also want to give her our beautiful handmade keyring. If you want to know how this was made, we have published on the social a video about how this thing was carefully crafted for our speakers. So please, round of applause for Gülçin once again.
Thank you.